Welcome to AI Unraveled, the podcast that demystifies frequently asked questions on artificial intelligence and keeps you up to date with the latest AI trends. Join us as we delve into groundbreaking research, innovative applications, and emerging technologies that are pushing the boundaries of AI. From the latest trends in ChatGPT and the recent merger of Google Brain and DeepMind, to the exciting developments in generative AI, we've got you covered with a comprehensive update on the ever-evolving AI landscape. In today's episode, we'll cover GPTs and LLMs, their pre-training and fine-tuning methods, their context window and lack of long-term memory, architectures that query databases, PDF apps' use of near real-time fine-tuning, and the book AI Unraveled, which answers FAQs about AI. GPTs, or generative pre-trained transformers, work by being trained on a large amount of text data and then using that training to generate output based on input. So when you give a GPT a specific input, it will produce the best matching output based on its training. The way GPTs do this is by processing the input token by token, without actually understanding the entire output. It simply recognizes that certain tokens are often followed by certain other tokens based on its training. This knowledge is gained during the training process, where the language model, LLM, is fed a large number of embeddings, which can be thought of as its knowledge. After the training stage, a LLM can be fine-tuned to improve its accuracy for a particular domain. This is done by providing it with domain-specific labeled data and modifying its parameters to match the desired accuracy on that data. Now let's talk about memory in these models. LLMs do not have a long-term memory in the same way humans do. If you were to tell an LLM that you have a 6-year-old son, it wouldn't retain that information like a human would. However, these models can still answer related follow-up questions in a conversation. For example, if you ask the model to tell you a story and then ask it to make the story shorter, it can generate a shorter version of the story. This is possible because the previous Q&A is passed along in the context window of the conversation. The context window keeps track of the conversation history, allowing the model to maintain some context and generate appropriate responses. As the conversation continues, the context window and the number of tokens required will keep growing. This can become a challenge as there are limitations on the maximum length of input that the model can handle. If a conversation becomes too long, the model may start truncating or forgetting earlier parts of the conversation. Regarding architectures and databases, there are some models that may query a database before providing an answer. For example, a model could be designed to run a database query like select asterisk from user_history to retrieve relevant information before generating a response. This is one way vector database can be used in the context of these models. There are also architectures where the model undergoes near real-time fine-tuning when a chat begins. This means that the model is fine-tuned on specific data related to the chat session itself, which helps it generate more context-aware responses. This is similar to how Speak with Your PDF apps work, where the model is trained on specific PDF content to provide relevant responses. In summary, GPTs and LLMs work by being pre-trained on a large amount of text data and then using that training to generate output based on input. They do this token by token without truly understanding the complete output. LLMs can be fine-tuned to improve accuracy for specific domains by providing them with domain-specific labeled data. While LLMs don't have long-term memory like humans, they can still generate responses in a conversation by using the context window to keep track of the conversation history. Some architectures may query databases before generating responses, and others may undergo near real-time fine-tuning to provide more context-aware answers. GPTs and large language models, LLMs, are fascinating tools that have revolutionized natural language processing. It seems like you have a good grasp of how these models function, but I'll take a moment to provide some clarification and expand on a few points for a more comprehensive understanding. When it comes to GPTs and LLMs, pre-training and token prediction play a crucial role. During the pre-training phase, these models are exposed to massive amounts of text data. This helps them learn to predict the next token, word or part of a word, in a sequence based on the statistical likelihood of that token following the given context. It's important to note that while the model can recognize patterns in language use, it doesn't truly understand the text in a human sense. During the training process, the model becomes familiar with these large data sets and learns embeddings. Embeddings are representations of tokens in a high-dimensional space, and they capture relationships and context around each token. These embeddings allow the model to generate coherent and contextually appropriate responses. However, pre-training is just the beginning. Fine-tuning is a subsequent step that tailors the model to specific domains or tasks. It involves training the model further on a smaller domain-specific dataset. This process adjusts the model's parameters, enabling it to generate responses that are more relevant to the specialized domain. Now let's discuss memory and the context window. LLMs like GPT do not possess long-term memory in the same way humans do. Instead, they operate within what we call a context window. The context window determines the amount of text, measured in tokens, that the model can consider when making predictions. It provides the model with a form of short-term memory. For follow-up questions, the model relies on this context window. So when you ask a follow-up question, the model factors in the previous interaction, the original story, and the request to shorten it within its context window. It then generates a response based on that context. However, it's crucial to note that the context window has a fixed size, which means it can only hold a certain number of tokens. If the conversation exceeds this limit, the oldest tokens are discarded, and the model loses track of that part of the dialogue. It's also worth mentioning that there is no real-time fine-tuning happening with each interaction. The model responds based on its pre-training and any fine-tuning that occurred prior to its deployment. This means that the model does not learn or adapt during real-time conversation, but rather relies on the knowledge it has gained from pre-training and fine-tuning. While standard LLMs like GPT do not typically utilize external memory systems or databases, some advanced models and applications may incorporate these features. External memory systems can store information beyond the limits of the context window. However, it's important to understand that these features are not inherent to the base LLM architecture like GPT. In some systems, vector databases might be used to enhance the retrieval of relevant information based on queries, but this is separate from the internal processing of the LLM. In relation to the Speak with Your PDF applications you mentioned, they generally employ a combination of text extraction and LLMs. The purpose is to interpret and respond to queries about the content of a PDF. These applications do not engage in real-time fine-tuning, but instead use the existing capabilities of the model to interpret and interact with the newly extracted text. To summarize, LLMs like GPT operate within a context window and utilize patterns learned during pre-training and fine-tuning to generate responses. They do not possess long-term memory or real-time learning capabilities during interactions, but they can handle follow-up questions within the confines of their context window. It's important to remember that while some advanced implementations might leverage external memory or databases, these features are not inherently built into the foundational architecture of the standard LLM. Are you ready to dive into the fascinating world of artificial intelligence? Well, I've got just the thing for you. It's an incredible book called AI Unraveled, Demystifying Frequently Asked Questions on Artificial Intelligence. Trust me, this book is an absolute gem. Now, you might be wondering where you can get your hands on this treasure trove of knowledge. Look no further, my friend. You can find AI Unraveled at popular online platforms like Etsy, Shopify, Apple, Google, and of course, our old faithful Amazon. This book is a must-have for anyone eager to expand their understanding of AI. It takes those complicated concepts and breaks them down into easily digestible chunks. No more scratching your head in confusion or getting lost in a sea of technical terms. With AI Unraveled, you'll gain a clear and concise understanding of artificial intelligence. So, if you're ready to embark on this incredible journey of unraveling the mysteries of AI, go ahead and grab your copy of AI Unraveled today. Trust me, you won't regret it. On today's episode, we explored the power of GPTs and LLMs, discussing their ability to generate outputs, be fine-tuned for specific domains, and utilize a context window for related follow-up questions. We also learned about their limitations in terms of long-term memory and real-time updates. Lastly, we shared information about the book AI Unraveled, which provides valuable insights into the world of artificial intelligence. Join us next time on AI Unraveled as we continue to demystify frequently asked questions on artificial intelligence and bring you the latest trends in AI, including GPT advancements and the exciting collaboration between Google Brain and DeepMind. Stay informed, stay curious, and don't forget to subscribe for more.